Welcome back, everybody. We are part 2 of chapter 2 or module 2, and we're going to be talking about histograms. A histogram is a graph consisting of bars of equal width drawn adjacent to each other. Adjacent meaning they're touching each other. The horizontal scale represents the classes of quantitative data values, and the vertical scale represents the frequencies. A relative frequency histogram has the same shape and horizontal scale as a histogram, but the vertical scale uses percentages instead. So here's some data, and here's the exact same data. This one is based on percent, and this one's based on frequency. And you can see they're the exact same shape. And below it is frequency and percent. And I have a few more here. So here is our normal curve. We talked a little bit about that at the end of the last video. This is called a uniform distribution. These are quite boring. Not a lot of fun information to get out of those. And we'll talk more about those later. Now, I want to point out here that for this, we have a longer tail on the right side. And here we have a longer tail on the left side. And when it's not centered like it is here, where we have a nice, pretty bell shape, we say that the distribution is skewed if it is not symmetric. Symmetric means you can put a mirror right there and the left side equals the right side. And you're definitely not getting that here or here. It extends to one side more than the other. Data skewed right have a longer right tail. So this is going to be skewed right. We have a longer right tail. Data skewed left have a longer left tail. So that would be like this one here would be skewed left. And by the way, we are going to have distributions that are not bell-shaped, that they are going to be skewed like this. All right, so let's do some practice. So we're going to set up a frequency distribution again, and then we're going to set it up so that we can make a histogram a bit down below here. This is a study. 20 students were randomly sampled and asked how many hours they had spent doing homework the previous week. And the data is shown below. I've put the data in order for us, so we don't have to put it into our calculators. They even tell us that they want us to start the lower class limit with 4. And they want a class width of 4. So remember, I'm going to add 4 to that to get there. Let's do that. Do that all the way down. Now, you don't have to draw these in like I am. I'm using it more as a teaching tool than anything. And if you remember how we find the upper class limits, well, I just look here. Here's 8. That means this is going up to 7. This one's 12. That means this one's going up to 11. And again, you can see I'm adding 4, add 4, add 4 as we do this. And I'm going to add 4 to that, and that's going to be through 23. So we have our limits. Now we need our class boundaries. If you remember class boundaries, that means we go up and down 0.5. So this becomes 3.5 through 7.5. I'm going to go down 0.5 here. That's going to be 7.5, and you'll note it's the same up to 11.5. Going down here gives me, again, 11.5 up to 15.5. 15.5 through 19.5, and 19.5 through 23.5. All right, so now we're going to look back up at our data, and how much data is between 4 and 7? Well, 2 values. How much data is between 8 and 11? 1, 2, 3, 4. We include the outermost, the boundaries here. And between 12 and 15, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. And how many are between 16 and 19? 1, 2, 3, 4 are. And how many are between 20 and 23? Just 1. So there we are. Now we're going to add the relative frequency. And if you remember how to do that, change colors here for a second. I'm going to take the total. There's a total of 20 students. And I'm going to take the frequency 2 over 20. Which if I divide that out, gives me 10%. 4 over 20 is going to double that. It's going to be 20%. And you can divide that out with a calculator. 9 over 20 gives us 45%. 4 over 20, we've already done, that's 20%. And then 1 over 20 is going to be half of that one. So that's going to be 5%. And if you added all that up, you would exactly get 100%. I would like to point out that this does look like it's a normal distribution, meaning most of the data is in the middle, and then it gets smaller and smaller as we tail apart like that. And what we're going to do is we're going to use this to graph our histogram. Now, on this axis, I'm going to go by 2s. 2, 4, 6, 8. Ooh, we need one more. 10. And on this axis, we are going to go with the class boundaries. So the lower is going to be 3.5, 7.5, 11.5, 15.5, 19.5, and 23.5. And I'm going to note that between 3.5 and 7.5, the frequency is 2. And we could shade that in if we wanted to. Between 7.5 and 11.5, we have 4. And between 11.5 and 15.5, we have 9. That's going to be way up here. In fact, I'm going to use a ruler for this one. There, 9 and then 19, between 15.5 and 19.5, we have a frequency of 4. And between 19.5 and 23.5, we have 1. And this is not the only way to make a histogram. I've seen many different ways. Occasionally, you'll see they will label on top what the frequency actually is. So here we have a 2, a 4, a 9, a 4, and a 1. Yeah, and if you use an Excel document, you could have even more options on what they look like. I hope that's helpful.